Hey there, freshmen. So yesterday we started learning about ions, or atoms that have charge. And another way of putting that was an ion is simply an atom with an unequal number of protons and electrons. And we talked about how if I have more protons than I do electrons, then I am positively charged. And if I have more electrons, I'm negatively charged. We also talked about last week how positively charged and negatively charged things attract each other. So a positive and a negative will grab onto one another, but a positive and a positive will push each other away, or a negative and a negative will push each other away. This is important when we're trying to figure out what atoms will stick together. For instance, fluorine is negative, and so is chlorine. You will never see fluorine and chlorine sticking together to make a molecule. That never happens because they're both negative and they repel one another. However, hydrogen is a positively charged atom, and I can combine that with fluorine just fine because it's negatively charged. Okay, so you always need a positive and a negative in order to make a molecule. All right, well, we're going to go ahead and kind of define what a positively charged ion is and what a negatively charged ion is. A positively charged is called a cation. Boink. And a negatively charged one, you could probably already guessed, is an anion. Now typically the an in front of a word gives it a negative connotation, but an easier way to remember this is that everybody loves cat videos on the internet. Cat videos are pretty positive, and the more that we get on the internet, the better. So, the cat part of the cation is positive because everybody loves cat videos. Okay, so with every molecule, you need to have a cation and you need to have your anion. And a good example of this could be simply what I just showed you, hydrogen chloride or hydrochloric acid, HCl. The cation is the positively charged hydrogen, and the anion is the negatively charged chlorine. Another one could be calcium chloride. Calcium chloride, as I erase these guys really quick, calcium chloride, I erased a lot there, anion, is CaCl2. This is a +2 charge, and this is a -1 charge. So this is my cation here, and this is my anion right here, the chlorine. It's negatively charged. Okay, so that should be fairly clear and simple, straightforward and to the point. So how do you know whether or not you have a cation or an anion? Well, you just got done working on a worksheet where you identified the common charge of different elements. And what you probably found out was everything in this row all shares the same common charge. And all of the atoms in this row share the same common charge. So you don't have to go through and calculate the number of protons and electrons every time. Nobody wants to do that, and it's not all that useful. So here is a nice, easy way to remember which atom is positively or negatively charged. And what I want you to do right now is take out your periodic table. Okay, so get that out. I'll wait. I'll give you like 3 seconds. Get that thing out. You ready? Okay, here we go. So check this out. At the top of your table, I want you to write these numbers down. Above hydrogen, I want you to put a +1. because everything in this column all the way down is +1. Okay, above beryllium, I want you to put a +2, because everything in this column right here is a +2. For this column right here, it's a +3. So everything right here is +3. This can operate as plus or -4, but we typically just say +4. After that, we get into the negatives. So nitrogen, in order to get over here, remember it wants to be a neon in terms of number of electrons. Well, in order to get over there, it's got to get 1, 2, 3. So 1, 2, 3 electrons to get there. Okay? Well, because of that, it has a -3 when it finally does do that, when it finally fills its outer shell. All right, the oxygens and sulfur and all of those are -2. Fluorine, chlorine, bromine, iodine, those are -1. And helium and all that jazz, the noble gases, they don't have a charge because their outer shell is already filled. So they don't have to add electrons to get to that complete outer shell, and as such their protons and electrons are equal. So this actually has a 0 charge. Okay, so now when you look at this, when it comes time to identify your cations and anions, your cations are these guys, right, and these guys right here. Just like that. And then your anions are these right here. So I can combine everything that's circled in green with something that is circled in yellow there on the screen. Okay? And just so that I clear up any confusion, the yellow is your anion and the green is your cation. Okay? So that should help you drastically in terms of figuring out what the charge of each atom is, because we actually have to match the charges out to have a balanced molecule. Otherwise, our molecule will be charged, and it will also be an ion. Okay? We'll get into that later, don't worry. So, you should have all of these numbers above each column on your periodic table ready to go so that you can use it from here on out, because we're going to be referring back to this several times. All right? Okay, I'm moving on to the next slide, and this is the last thing I'm going to do in this video, is quickly show you how to fill this out. So potassium is P and oxygen is O. We need to know their charges really quick. So potassium, or sorry, that's phosphorus. Yeah, I said potassium. Yeah, potassium is K, so that's right here. And oxygen is -2, that's right here. Okay, so I have potassium, that's +1. I have oxygen, that's -2. Okay, when I go over here, I'm going to figure out a chemical formula for putting these two things together. Before I do, let me go on ahead and identify them. Potassium was my positively charged ion, right? So potassium is going to be my cation. So I'm going to put K there because it's asking for my symbol of the ion, which is K. My negatively charged one is the oxygen. It's got a -2 charge. So O goes here. How many do I have of each one? Well, what we're trying to do is balance these. So since oxygen has a -2 and potassium has a +1, how many potassiums do I need to equal the charge of the oxygen? Well, I would need 2 of them in order to do that, right? Because if I have 2 potassiums here, well, now this goes up to 2, and when I add them together, they cancel each other out and give me a neutral chemical formula. Okay, so then that means I only need 1 oxygen right here. So check this out. When I go K2O, I have my 2 +1 charged potassiums here, and I have 1 of my -2 charged oxygens here. So that is my chemical formula. Now they are a happy neutral molecule. They're all happy and good to go. They're balanced. So this is the process that you're doing for the other ones in this table, okay? That is all you need to know at this point to complete that assignment. This was cations and anions. I should be back tomorrow, Thursday, but we will go over this stuff on Friday. And if you don't get to this by the end, well, you'll be getting this again in person. So, all right, talk to you later, freshmen.